recording now. So first of all, I should set I think the deadline for your project is today midnight. Today's midnight. And I saw some questions from some of you about, I think there was one person who couldn't send the whole project to me, but I will, at the end of this lesson, I will show you, you don't need to, for example, send me your build folder or the debug folder. You don't need to send me those files. If you delete those ones, you don't need to upload much data. So I guess then you can send it so fast. But just sending me one .sln file, it's really nothing, because I saw one of you sent me just one solution file. That solution file is nothing. I don't have any code from that. It's just something that's arrange your project or arranges your solution, not your source code. So I cannot confirm to, I cannot accept that as a project, as your first sub project. Okay, we will. I will show you at the end of this lesson which files you should send to me and which files you don't need to send it to me. Okay, today we have our the lesson 7. Last time we discussed about classes and most important topics about inheritance, and today we are going to talk about the rest of topic that remain for inheritance specifiers, cost functions, virtual inheritance, and then we will discuss about interfaces and abstract classes. The last topic that we will discuss about is how to create a DLL and Qt project. I took so many screenshots from every steps that you need to do to create a dynamic link library project and a Qt project. In the next lesson, I will show you some examples in Visual Studio to work more with Qt library and also your dynamic link library. And the last topic that we are going to discuss about are threads. And we will discuss about that in the next lesson. Probably the next lesson, not the next class, because the next class is for electrical engineering students. We're going to evaluate their project in the next class, and next Monday, and the other students will not be present. And what else? And the last topic, which would be the last lesson of, not the last, kind of, but in last class, we will only discuss about your projects. And if you have any question about C++, about your last project, we will discuss about. After you sent me, all of you sent me your project by today's midnight, I will send you the last, your final project definition. It would be again related to your first sub project, but it involves to have a dynamic link library. Most of the things that you implemented in your console application, We will be transferred to a dynamic link library. You will write some interfaces for them, and you will learn interfaces today, but you will write some interfaces for your classes. And instead of communicating and interacting with your with the user of your program in console application, in your using the command line, you will use the Qt project to visualize data better, because it was a good thing that most of you usually ask me, okay, what should I show to the user after loading? What should I show to the user after selecting and having some queries? In console application, you didn't have much freedom to implement your ideas. It's difficult to interact with your user only through the command line. But we were trying to make it easier for you, and we didn't expect much. We don't expect much for your console application, for the first sub-project. But for the second, it would be the final project, you will interact with your user using through the Qt GUI. The last topic that we discussed in the last lesson was public inheritance, and was overloading and overriding. And we learned how to inherit from a class. But the thing that we learned at that time was that we only inherit from other classes through one specifier whose name was public. And that's exactly the most common one. Just wait a minute, I need to bring something. Sorry. 2 days ago was our New Year, our Persian New Year, and I'm still not ready to teach, and my stuff are not here, my computers are not here. So that's the problem. I was saying that for getting the inheritance, we wrote, for example, I can write it here to let you, just to remind you how it was. To have, the typical way of having inheritance was like this: class, the name of class name. Okay, let's write it like this: child, and we had I think it was like this: public and the parents. So we had something like this, a specifier that defined the way that we were inheriting from another class. Today, I'm trying to explain that this is not the only way that we can inherit from another class. We have also the other ways. We can write here private, we can write here protected. But the public one is the most common one. The others are not really common. So for public, if we inherit from another class through this specifier, which is public, the members of this parent class who are public would be a public members of the child class as well. If they are private, we do not have access to them in the child. If they are protected, they will be the protected member of the child as well. So these are coming from the parents. These are belongs to the child. So if you these are the access specifier that we used to define the members of the base class, and these are the resulting inherited members in the child class. If we use public specifier when we are getting inheritance from another class, it would be like this. I mean, they will be translated like this. Okay. But if instead of public we use private, I mean here, if we write private instead of public, then the public members of the parent class would be a private member of the child class. The privates are still inaccessible in the inherited class, in the child class, and the protected one would be also private. This one is really, it's not really common. We usually use public. And the last one is, instead of writing public there during the inheritance, we will write protected. And the public members of the base class would be protected member of the child class. And the private one are still inaccessible. And the protected one would be protected. So this one is really rare, and you won't see this. But you should know that if you see something like this in any source code, you should be able to understand that. Sorry. So can you tell me what is the output here? These are mostly related to the topics that we discussed in the last lesson. So I hope you remember what we said about the constructor and inheritance. And let me show you here. Can you tell me what is the output here? Or if you cannot remember, just explain what is happening here at least.
So an object of the class derived is being constructed in the main function, and the constructor dictates that just the command derived should be outed into the command center, should be outed as a line. That is what will happen.
You think something is wrong? No, nothing is wrong here. I just want to know how the constructor and destructor will be called when we have this command in the main function.
No, I didn't think anything was wrong. I just thought that there would be just outputs during the construction process.
I'm not sure I got what you said. Okay, but can you explain more?
Well, so the constructor of class derived is called, and in that method you have std cout and then just a string, and so there's going to be an output of a string.
So you don't have any opinion about the destructor and also the constructor and destructor of the parent?
No, because they are called, only the constructor of derived is called.
Mm-hmm. Okay, thanks, Sam. But in fact, all of them will be called. And okay, first of all, I said in the previous lesson that unlike Python, here when you are calling a derived class, if, for example, the constructor had something here, I had to here create an instance of the base class, which I think I can show you the previous slides just to remind you. 6. Inheritance. Okay. If you look at this slide, you can see here we have human and we have employee, which is inherited from human. And as you can see here, this is the constructor of employee. And we are calling the constructor of human to be able to create an instance of human for employee. Otherwise, we will not have access to these members. I mean, our code would not be compiled because we wrote here public human. So the pattern in C++ is that we will write this, also we will write this one. This one will create an instance of human. This one is saying that we are inheriting from human. But in this example, nothing is written. But if you remember, we said that we have, if we for our classes, if we do not write anything, it's similar to calling the default constructor. This is the default constructor, and if I do not write this, it will just call the default constructor, since this class has a default constructor. And what was the definition of the default constructor? The definition of default constructor was that it doesn't have any input arguments. So if we have default constructor, and if we are inheriting from that, and if we do not have any other constructor, so we do not need to write this statement, but it doesn't mean that it's not written here. The compiler itself will write this, will call base here for you. So unlike, again, Python, here, when you are creating an instance of the derived class, an instance of the base class will also be created. And when an instance of a class is created, it means that the constructor of that class is called. So till now, we know that these two will be called. But first, the base class will be called. As you can see here, first the base class will be called, then the body of the employee will be run. So if here we have derived.d, first, this part, which you cannot see, but you know that the compiler write it for you, will be called. So it is this one. So the first thing that we will see in our console is this statement. Just base parentheses. Then the body of the constructor of the derived class will be called, will be run. But here we have a scope. And as you remember, I hope you remember, when we go out of the scope and we define something in our stack memory, that object will be erased, will be gone. So, But what does it mean when we say that that object will be erased? It means that the destructors will be called. So first, the destructor of the derived class will be called. Here we do not have something to be written. Then, since we also have an instance of base class, the destructor of the base will be called. So what we will see in the output is base, derived, this derived, and then on tilde base.
Then I have a question. Then why does it? If that's the case, then how can you override the constructor of your parent class? For example, in Java, you can just do that if you don't mention the constructor of the parent class in the child's constructor. Then it just overrides it, and you can do something entirely else for the child class. Isn't that possible then in C++?
It is possible. You are doing that right now. So as you can see, you have the derived here. For example, maybe I have another example here. I can show it to you. But this one has exactly the same. How can you do that one? Just give you an example. But what you are doing, I mean, here you are overriding that one. But if you really want to have different arguments, from, I mean, have some arguments different from the constructor of your base class, then you will have to, for example, here you have two different constructors. Here you have one constructor. This constructor, we call only one of these constructors. It doesn't have to call all of them. So then this class can only use one of the constructor, not both of them. I mean, the user of your derived class only call that one and only be able, it will be, he or she will be able only to use that type of constructor of your base class. Maybe I can give you one example. For example, here you have, you are saying that, for example, this one has, okay, it's difficult to write it in. This one has int, imp, and something. It has a body. It will do something here. But here with this one you are only calling this. You can write here, for example, instead of this, we can write base imp, and here you will also have int imp. So with this one you will call one of the constructors. So you can also call this one. You can have other arguments. For example, you can have double something here and use it in the constructor of yourself. I mean, sorry, imp 2. And you will use this one for yourself here, or for, I mean, other thing in your class. So you are overriding this one. This is not exactly this one. Actually, you are not we can say that this is not overriding. This is overloading. With overriding in C++, for constructor, we do not have overriding. We have overloading. I don't know if you have it. For example, can you give me an example of overriding in Java? Because in overriding, we have the same number of inputs and outputs.
Maybe overwriting was the wrong word because of its other usage, but I would actually say something like, if you have a child class and you don't implement the constructor of the parent class in the child class, you can actually just skip the constructor of the parent class which is something you can't seem to do, because if you just what was the clause again? If you just call default constructor of derived, there was no reference to the parent constructor in the child constructor. There was no base constructor in the child constructor, yet it was called, which is something that's maybe isn't, which is something you maybe don't want. So the question was if there was a way to not overwrite, that was the wrong word, but to skip the parent constructor.
No, here you have to, I mean, what you are asking is exactly what's happening in Python as well. I'm not familiar with Java, but in Python, it's exactly like that. So, and the reason is that the classes are just some pattern for the child classes. So they are not objects there. You know, I mean, we have so many different keywords to say to explain many different topics. So I hope you are getting what I'm saying. But
I'm getting it. I'm getting
okay, but here we have all the classes are. When we are inheriting from another class, it doesn't mean that we are inheriting from a template, from a pattern. We are inheriting from an instance of that class. But in Python, it's not like that. In Python, we are inheriting from the class itself. You know, there we do not create any instance. The classes are just some pattern, and then we inherit from that. So because of that, we don't need to create any instance of the class. But here we are inheriting from the instance of the class, and because of that, we have to create an instance of that like this.
Thank you.
Okay. Before destroying my slides. Okay. Please. The Control C doesn't work. Oh, okay. No, this one is okay. So, what is the output here? Okay, just to help you, there is something is wrong here.
Why isn't in the constructor of derived integer y, why isn't base y inside the brackets?
No, this one, if you want to initialize something, you can do it like this.
Oh,
like
okay.
what you can see here, you see. You can also use it for other data types. I mean, for example, you can write here M salary and assign it to something. But there is another error. Read it from the beginning of the base class, then you will see that.
Maybe from your derived and then void print, you're calling mx, but it's private in the base class?
Yeah, exactly, correct. So this one is private. And as we said, we do not have access to the private member of the base class in the derived class. So here we will have a compiler error. And what is the output here? Nothing is wrong. And why nothing is wrong?
Okay, so first you call the constructor derived, which first calls the constructor of base with an integer in front. So first base will be outputted to the console, then derived.
Mm-hmm.
Then you set the derived integer to 6, which is a function in the derived class. So it just does it. And then it returns 0. And then, of course, the destructors are called again. So then it's apostrophe, I think it's in English, base, and then apostrophe derived also outputted. I think.
Okay. No, for the destructor, the order is the other way around. First, the derived will be called, and the base will be called. But can you tell me why we do not have any problem here now? Because in the previous example, we had a problem.
Now it is protected and not private.
Yeah, exactly. Because since it is protected, we can have access to that in the derived class. Okay. What do you think about this one? Have you ever heard about, I mean, can you see the change?
Mx will first be 5 and then 6.
No, but the, I mean, just point out the change that you can see here. What is the difference between this example and, sorry, this example and this one? You see?
In the setX method in the derived class, there is a constant now.
Mm-hmm. Do you know that? Have you seen that before?
No, I haven't.
Okay. So this is a new term that I'm explaining this to you. When you have, after your member functions, when you write const, it means that this method cannot change the data member values of data member variables of this class. And since mx is also a protected member of the derived class, it means that it cannot change, and it will give you a compile error. But why we have this, when this keyword will be useful for us? Not for the setters, of course, but for the getters, it's good to put the const at the end, because the getters are just some things that are supposed to return some value to the user of the class. So for them, you can write const, and it means that if you change any data member in the body of that function, you will have a compiler error. These are a good practices for writing your programs. So these are not something you see. They are not doing. I don't know how to say, but they are not doing a special thing for you. What they are doing, I mean, they are not, for example, they are not a binary search, or they are not getting a memory. So they are just some good practices to design your program, that you know that if this is a getter, if this function has the const at the end of that, when it's getting defined, it means that these functions should not change anything. So, and after a couple of months, when you come back to your code, you know that there is a const here. So based on your design, this one should not change anything. So after a couple of months, you know that you should not change. You should not. This is by design should be like this. If you change it, you will have the compile error. So these are some good practices to help you to design your program. Now we're going to go to multiple inheritance. We are not going to the details. I guess in your in Java you don't have multiple inheritance, but in Python and C++ you have multiple inheritance. But I'm going to give you just some examples of the common problems that you may have with multiple inheritance. If you go, for example, to a job interview, they usually ask you such a question. They show you some use cases about multiple inheritance, and they will ask you, okay, what is the problem here? How can we solve it? So the next slides that you will see are just some examples like that. So to have multiple inheritance, you can see here we have class A, we have class B, and we have class C. Class C is inherited from A and B, as the diagram shows. These two classes are includes one function member with the same name. So they are, as you can see, they have the same name, they have the same signature, everything is the same, but their body is different. Okay, here the only difference between the body is the message. Here is A process and here is B process. Class C is inheriting from A and B, and when we are going to call c.process, we will have a compile error, and it says that the request for member and process is ambiguous because C doesn't know which one should be called, because it has this one is public, this one is also public. So since we are getting inheritance from B and A as with public specifier, it means that these two would be public members of the class C. But which one should be called? Class C has two of them. So it's ambiguous for class C. What you can do, which is not really recommended, is doing something like this. You will write C.A and colon and process. So what you are doing is here is that you are calling the class. I mean, you are calling the method of this class. It's like you are hard coding your program. It's not really dynamic. The compiler itself cannot detect it, and because of that, you have to hard code it like this and ask the compiler to call the process from the A class. But it's not really good to do like this. What you can do is that to use this one in the definition of your class, you are saying that in the class C using a process. So it means that you are solving the ambiguity and you are saying to the compiler, use this one if I call process, don't use the other one. So now this one will not give you any error, and it will call the process from the A class. But these examples are not really good examples. I mean, you should not design your program such that you will have such problem. You should not have two methods in two parents class and inherit from both of them. In really rare cases, it may happen, but you should not do it yourself. But these are some things that, for example, you have one class from one library, you have one class from another library, and both libraries are, I mean, every library has been implemented by different companies, for example. Then you are, in very rare cases, you want to get inheritance from both of them, then you may have such a problems. But in your code, you should not implement your code like this. I mean, you should not design your code such that you will reach to this point. So, but if you go to an interview and you saw such a thing, you should have an answer for that. And the answer would be this one. What else? Another example is like this. You will see here we have class A, B, and C and D. A and B and C, all these three have the same member function. Their signature is the same. What does it mean by their signature? It means that the name and the arguments are the same. Okay? And their body is different from each other. A and B are just some parents. C is inheriting from both of them. Okay, just ignore this term for the moment. And class D is inheriting from B and C. So when we are calling class D here, the process member of the class D, it doesn't know which one should be called. It's inheriting from three different classes. From this one, it's a grandchild of A, it's a grandchild of B, it's also a child of B. It's also a child of C. So to solve this ambiguity, we have another thing in C++, which is called virtual inheritance. You are familiar with virtual term, but at that time we use it for our member functions. Now we are going to use it for while we are getting inheritance from that. What does it mean? Virtual inheritance is a C++ technique that ensures only one copy of a base class members. Here, for example, member variables are inherited by the grandchild derived classes. So what I'm doing here is that I'm inheriting in class C, I'm inheriting from A, just like a regular way, but I'm inheriting from B with virtual. That ensures that the grandchild here, D, will only have one copy of this process method from B. Okay, so even if we are getting inheritance from B in two different ways, but only one of them will be passed to D. Okay, and in the class D, I'm inheriting from virtual C, from C by virtual, from B also by virtual. So what's happening here is that only one instance of this one will come for D, and one instance of B will also come for D. But these two will be overridden by C. So because C has also implemented, overridden the process here. So because of that, since we have used these virtual terms here, when I call d.process, the process method from C will be called. So again, this is not something that you are going to do for your project. These are just something that I'm teaching you because I think these are really useful to know. But for your project, I really don't expect you to, I mean, it's not really good practice to have such a complicated structure in your program. At least in your project definition, it would not be that much difficult that you will have so many classes and multiple inheritance. You will have multiple inheritance, but I think so. But not like this. It would not be, it will not have multiple member functions with the same signature in different classes while you are inheriting from them. What was that? Don't know. So what we have here is diamond inheritance, which is really a famous problem in many languages. But how can we solve it? In Python, this is not a problem because there we have method resolution order and it can solve it easily. But here in C++, it is a problem and we should solve it. But again, we will solve it with virtual inheritance. we have here two classes, B and C. Both of them are inheriting from A. A and C A and C include process with the same signature in their class definition. D is inheriting from B and C. Okay, again, we are calling the process method from D. So again, it's ambiguous if it should call the process from A or it should call the process from C. What we are doing here is that we are saying that, the class B should inherit from A by public virtual, and the class C also should inherit from A by virtual, and it means that only one copy of A will be passed to D, and that one copy will be overridden with C, with the process method in the C. So again, when we are calling here d.process, the process method of C will be called. So that was the diamond inheritance. If you go for an interview, they will ask you, okay, what is diamond inheritance? And then you will explain that we have two different classes inheriting from one class, and we have another class that is inheriting from the two classes. And then to solve this problem, we have to use virtual inheritance. In some interview, they may not refer to the term diamond inheritance. They may write a diagram like this for you, draw a diagram like this for you, and ask you, okay, how can we solve it? And then you have to answer like this. Another example that we have here is that this one is a problem in Python, but it's solved in C++. In C++, we have two classes. C is inheriting from A. C also is inheriting from B, and B is inheriting from A. So we have two. We have process from B and A. So to solve this again, we are saying that we should get inheritance from A by virtual. So only one instance of that will be passed to the class. One copy of process will be passed to the grandchild, to the C, and that one will be also overridden by the process from B. And because of that, when we are calling this process method from C, the process method of B will be called. Here, don't ignore this one, it's B, the output is B. So this is the virtual inheritance, and we also learned about using when we have this one. You saw that we can also use using to solve the problem. Here we cannot use virtual inheritance because we do not have any grandchild. The relationship is just between the parents and the child. But here we had inheritance, multiple inheritance between the child, parents, and grandchild. It can be more than this. You can have more ancestors, including in this inheritance, but all of them can be solved by virtual inheritance. There are some use cases that we cannot solve them, but they are not really good use cases because you should not reach this scenario. You should design your program that can be solved easier, and that's why in some languages we even don't have a multiple inheritance. So, but in C++ and Python we have, but the way that they are solving this problem is different from each other. So the next topic that we are going to discuss about are interfaces and abstract classes. These are something that at least you will need to implement some interfaces for your project. So these are some things that you will do in practice for your project, unlike the previous topic. what is interface and abstract classes? Abstract classes, any class with one or more pure virtual functions becomes an abstract class, which means that it cannot be instantiated. You have this one also in Python, you have this one also in Java, and you have it also in here in C++. So in an abstract class in C++, to define that, we do not have any special term for that, unlike what we have in Python, for example. But here, the only thing that results in an abstract class is that class includes one pure virtual function. In the next slide, you will see what is a pure virtual function. But if a class includes a pure virtual, at least a pure virtual function, at least one pure virtual functions, that would be an abstract class, and it means that we cannot instantiate from that. So any derived class from the abstract class has to implement that pure virtual function. Otherwise, if it doesn't implement that pure virtual function, that derived class will be an abstract class as well. What is an interface class? An interface class is an abstract class that has no member variables, and all the member functions of that are pure virtual functions. So the base classes, they are usually base classes where you have to derive from them and then implement the pure virtual functions. This is something that you will use as for example, when you are going to share some of your code with, from your dynamic link library with the user of, with your GUI, which would be the user of your dynamic link library, you will define some interfaces for your classes. You have a DLL, you don't want to share the code, you don't want to let the user see how you implement this, for example, your human class. In that scenario, you will write an interface for your class, and you will only share that interface with the user of your dynamic link library. And as we just said, that interface has no code, and the body, it only includes some pure virtual functions, and the implementation is in our classes, in our dynamic link library. So when you are going to share your code, you will only share the interface, not the code itself. And why? Because the interface classes has no code. They only have some pure virtual function. The implementation is in your derived classes. We will see some examples in this lesson today. Okay, what are different functions that we can have in a class? We have a class here. This one is just a normal non-virtual function. You are familiar with this one. There is nothing, I mean, it's just a function that receives anything. It can receive any arguments, and it has a body, and it's returning also something here. We have a normal virtual function. Again, you're familiar with this one, and the meaning is that if in the derived class this function is overridden, call that one, not this one. We discussed about this one in the last lesson. If you cannot remember that, go to the slides of that lessons or watch the video again to understand what I'm saying. This one is a pure virtual function. As you can see, it doesn't have any body, and instead it has equals 0. The rest is the same, similar to others, but it doesn't have any body and it's equals to 0. But this one is nothing. It's a compiler. It will lead to a compiler. A compile error. It leads to a compile error. So again, because this class, imagine we do not have this one and we do not have any compile error. We only write this one. And because of this line, this class would be an abstract class. So in the main class, when I try to instantiate from this one, it will not be instantiated and it will lead to a compile error. Why? Because we cannot instantiate from an abstract class. We should write a derived class for this one and implement this one, and then we can instantiate from that one. If you want to understand why we cannot instantiate from that, the logic behind that, you can think that, okay, if we write this one, if we instantiate from the base class, we are going to call a function member of this class, which is getValue. But getValue has not been implemented. So because of that, we cannot instantiate from abstract classes, because the reason is that we do not, we haven't implemented getValue. So since it's not a completed class, it's better not to be instantiated, and because of that we cannot instantiate from that. So let's see one example of that. We have class animal here. This class has a constructor. I'm initializing its data members. Here I could write this one, like m_name equals name inside the body. But I explained to you that we can also do it like this, because, okay, it's just one assignment, why we should write it in the body of that. But if you need to do some process before on name, before assigning to mname, you should do it in the body of the class. So here we have a get name here. It's just a getter. I could write, for example, here const, and that would mean that get name will not change any data member of this class, and it would be correct because get name is not supposed to change anything. It's just returning mname. But here, this will make this class an abstract class. It's a pure virtual function. It doesn't have any body. What we have here is a derived class cow. So animal, the class animal doesn't know how to speak, because we have different classes, we have different animals, and all different animals speak differently. Sorry. Different animals speak differently. So what we are going to do is that for every animal, we create a class and we inherit from this animal, and we implement the speak function. So what we are doing here is that we are calling this, here we can call the instance, because we are going to re-implement that function. So it's okay. Even if we cannot create an instance of animal outside of this class, like what we saw here, We couldn't do this one. But when we are getting the inheritance, we can do that. And we should do that. And here I write the body of, I implement this speak. If I do not write this one, then the cow class will be also an abstract class. So here I create an instance of cow because it's not an abstract class. It has implemented this pure virtual function. And now I can call cow.getName, which is this function, and cow.speak. Something I should add, here the convention, the naming convention is not correct. It will not lead to a compile error, but don't do that for your project. It should be, since it is public, it should be with a capital letter. Also here for speak, it should be with a capital letter. I mean, based on the naming convention that we considered for our project. In some companies, they may follow this naming convention, but for our projects, it's better to use the naming convention that I introduced to you in the project definition. So a pure virtual function is useful when we have a function that we want to put in the base class, but only the derived classes know what it should return. So as you can see here, cow knows that how to speak, but animal doesn't know how to speak. So because of that, we write this one as a pure virtual function, and we are forcing all the derived classes to implement this. If we do not write this here, we may have some animals that cannot speak. Why? Because we may forget to implement speak. We should be able, we should know that we have some objects inherited from animals that have name and that can speak. But for animal, we don't know how to speak. The derived classes are responsible to implement that. So a pure virtual function makes it so the base makes it so that version base cannot be instantiated, and the derived classes are forced to define. Yeah, these are the thing I just said. This helps ensure that derived classes do not forget to redefine the functions that the base class was expecting them to do. Yeah, these are, I just said that. But you are familiar with polymorphism and pointers, and in the last lesson, I discussed about dynamic casting. I discussed about how can we have a pointer referring to of type parents referring to an object of the child class. Okay, if we can combine those topics with abstract classes, let's see what we will get. We have a cow here, just as regular variable, and it has a name. It will return the name, and it will speak. But here I'm creating a pointer of type animal and setting that to an object of type cow. So even if we cannot instantiate animal, but we can have a pointer of type animal. That pointer is not an instance of animal. It's just a pointer referring to an address of type animal. Okay, don't confuse them with each other. Here we have animal, we have a pointer of type animal, but it's it includes an object of type cow. So now if I call the get name from this one, it will call the name of the cow. I mean, the name of that, and also speak from this one. Even if animal has not implemented speak, but cow has implemented that. And because of that, we can call it like this. But we cannot do this one because animal is an abstract class. Try this one with more exercises, with more examples, and try to understand it better, because I think you got that. I don't know if you have any question you can ask, but you need to practice. Otherwise, you will forget it very soon. So what is till now we learned about abstract classes, but for interface classes, they are, as we said, they are exactly like abstract classes, but the difference is that they don't have any regular function. All the functions that they have is pure virtual functions. They also don't have any data members. So here we saw that we have a data member, we have some regular functions for our abstract class, but we don't have it for our interface class. So as you can see here, for our interface class, we only have pure virtual function, virtual pure. Okay, and the destructor of them should be virtual as well. I said this in the last lesson because the reason was that, like what we saw here, we will assign an object of the derived class to the to a pointer of the parent class, and if we and it means that if we have a virtual function, if we have this one, then we have to make the a destructor of animal virtual, and it means that when this animal is going to out of the scope, then the destructor of cow will be called. You are familiar with virtual keyword. We said that virtual keyword is used when we use virtual keyword if for a function, if that function is overridden in the derived class, then the overridden function in the derived class will be called. So again, here, if the cow has a destructor itself, then when animal, this variable is going to go going out of the scope, then the destructor of cow will be called, because the destructor of animal is virtual. This is really important. You should really make for your interfaces sorry, make them make your destructor virtual. So let's go to the DLL and Qt project, and you will see how you can use it. You can use interfaces in your project, and how you should do that. Take these slides very seriously. Do it at home. I add one screenshot of every step, and also some examples how to communicate between the dynamic link library and Qt project. But we are not in the class, so I cannot ask you to do it now. I will explain every step. You can rewatch the video at home, and you have to do it at home from tomorrow till the next Monday. I expect you to spend some time to do these steps, these steps from 1 to 6. I will explain them to you today, but you should do it at home, because you need to create such projects for your final project. And if you have any question in the next lesson, you can, yes, in the next lesson, but not next Monday, because next Monday we have the evaluation day. But again, I said it multiple times, do it at home. Otherwise, in the after just, I think it's in May, you will come to me and you will say that, okay, I cannot create this project, and it's too late. Then at that time, it's really too late. So try to follow this step and do it at home in this week after sending me your first sub projects. So the first step is that we are going to create a Qt project. We are not going to discuss about Qt library today. Not much. We only discuss what the commands and the classes that it has will not be discussed today. In the next lesson, we will discuss, but we are going to learn how to create a Qt project and how to create a dynamic link library and how to connect them with each other. So the first step is to create a Qt project. So you know how to create a project, exactly similar to how you created a console project. You will go to the file and then new project, and there you will go. If you follow the structure that I sent to you, and you installed Qt for your Visual Studio, then you will have this one. You have installed, and you will choose this one, Qt GUI application. You set a name. It's better to set it like that, a store GUI, and you define a path for that. For example, here for me as teaching DLL, this is the folder that I'm going to create this project. It will create one folder including the whole solution. So set a name, path, choose this one from Qt here, and then press OK. If you press OK, the Qt GUI Application Wizard will be open for you. Here you will only press Next. From this menu, you choose GUI and Core. And then you will press Next. In this window, what the Qt GUI Application Wizard is doing is that it's trying to it's creating for you the first class that you need for your GUI. Usually the first class is your main window. You will have a main window that your user will use that to interact with your program. So we name that class main window like this. This is the class name, and we are using the camel case format to name that class. It's inheriting from the base class, which is QMain window. It's a class that is defined in the Qt library. This is not something that you define. This one is something that you are going to define. This class has, at least for the moment you are saying that it's to have this class, you will have 4 different files. In the but finally you will see that you will, for every class in Qt library, every class that is implemented with Qt library will lead to 5 different files. So the first 2 files are the files that you are going to work with. These are similar to the files that you have when you are defining a class for your project. It's just one header file and one CPP file. Okay. Then we have main underline window .ui. What is this one? this is the file in which you can define your widgets. For example, you can define a text box, you can define a label, you can define a menu. So this file is in fact an XML file that defines your GUI. But the functionality behind these objects are implemented in main.window.h and main.window.cpp. What is this one? main_window.qrc. This is a file that's includes your resources. For example, your icon, the path to your images. So these are the things that will be here. So for your project, we don't expect you to work with this one. But when you build your Qt project, another file will be created whose name is UI_main_window.h. What is that one? That's an automatic file that is built by the maker of your Qt project. But we will see it later. So that file is generated automatically. You're not going to change it. You are going to only work with these two and this one. For this one, you're not going to work with the XML file. You're not going to write XML code for me. What you are going to do is that you will open this file in Qt Designer, and you will work with Qt Designer application to add some objects to that. But to implement, for example, to implement the code when you are clicking on one item, or you are changing the text in the text file, to implement those codes, you have to use main_window.h and main_window.cpp. In the next lesson, we will see some examples on that in Visual Studio. I will run some code for you, and you will see how you can implement them. So you will name these things like that, and then you will press finish. If you press finish, you will see in your Visual Studio something like this. You have one solution file named store GUI, one project here, source file main.cpp, main_window.cpp, main_window.qrc, main_window.h, and main_window.ui. And if I build this one now, but don't do that, if I build this one now, it will create UI_main_window.h as well for us, which is something that is built from main_window.ui. And you're not going to change it at all, because in every change, every build of your program, it will be changed automatically. So in main_window.cpp, you will see something like this. It includes main_window.h, and it's inheriting from it's inheriting from a parent, which is QWidget, and sorry, it's inheriting from parents, which is QMain_window. Sorry, and and it has an input argument, which is parent. So these are automatically generated for you, and you're not going to change it. And this one also calls this UI is created in the .h file, I mean here, but it's the code behind that would be in the file that is automatically generated for your Qt project. So the next step is to create a dynamic link library. So again, in your solution file, while you have this one open, okay, you will go to File and then press New Project. And here from this menu, you will choose this one, and then here Windows Desktop Wizard, and you name it Store. And here in your Store GUI, okay, I don't know why. And you will here you will create a folder name whose name is exts, which means that it's externals. So in your Store GUI, you will have a folder where you put your external libraries. You can put, for example, Boost library there. You can put any library that you want to work with. So you will put it there. This is just a folder that's a practice that we are using. So for some, I mean, it's very common to be like that, but I mean, that folder has no meaning for Visual Studio. You should change the project properties such that it will have some meanings for your for Visual Studio for your projects. In the next slides, we will see how to do that. So store, and with this one, and press OK. From this menu, if you remember, when you were creating your console application, you chose here another option, which was in Windows Console, I think. But now you're going to choose Dynamic Link Library. And you press empty, and the others are unticked. And then you press OK. If you do that, then you will have another project in your solution next to your Store GUI, but it's an empty project. So you will go to this path, Store GUI, ext store. So it's the path that our library is inside that. As you can see, this is the project file, store.vcx project. It means that this is the project file. Inside that, you will create two folders. One of the folders name is include, and the other one is this RC. Include is used to place the files you want to share with your Store GUI or any other projects that are going to use this library. src is the folder that you will put your code that are private to your library. So in include, you will have, for example, data underline type.h, that we saw an example of that in the previous lessons, that it was somewhere, it was a location that you define your error types and the function that convert that error types to some messages to the user. So that file, since it's going to be shared with your Store GUI, would be in your include. What else can be inside include? The other ones are the interfaces. We just learned about interfaces, and I explained to you, if you want to share some code from your library with other projects, you should write an interface for those shared code. So if we, for example, we have human in src, we have human.h, human.cpp in src, and now we are going to share it with the Store GUI. We have to write an interface for human and put it in include, whose name is i_human.h. So you will just, in this step, you will just create include and src folder in this path. Now, as I said, this folder has no meaning for your projects. So to be able to change the projects such that these folder has some meanings for them, we have to change the project properties correctly. How can you access to the project properties? You will go to here, that's me, here. You will right click on the name of the projects. And if you right click, it has in the pop-up menu, you will have properties. If you open that, you will go to this, I mean, this address, I don't know how to say, but in the left side, you have configuration properties, then general output directory. For these properties, you will write this one, solution directory, underline build, platform, and configuration. What does it doing? What is it doing? We are saying that the output directory for a store should be this address, and the output directory for store GUI should be this address. This means that the output directory for both of them are the same. But why? Why we are doing this? In a store library, if we build this one, it will generate a .lib file and .dll file for us. Store GUI, once it needs to work with a store, need those files, and that DLL file should be next to the exe file that the store GUI will create. So if you build a store GUI, it will create one exe file. To create that exe file, it needs the .dll file from a store library, and it should be next to the exe file generated by the store GUI. So because of that, the output directory of both of them are referring to the same location. What is these terms? These things are when you create a project in Visual Studio, it will, and these variables are defined by the Visual Studio itself. Solution dir is referring to the location your solution file is, where your solution file is. Your solution file names is has an extension .sln. So this is the path, this is the variable referring to that path. And we are saying that in that path, there is a folder whose name is underline build. And also there is another folder whose name is our platform. For example, x64, x32, this is the platform of your PC. And the configuration, what is the configuration? Debug or release. So when you are doing this, you should do it for different configuration. As you can see here, we have platform and we have the configuration. So you can write it for all configuration and for the platform that you want with these things. So as you can see, for here, I said that configuration properties, general output directory, and then you will write this. Configuration properties, general. If you click on this one, you will see here some things, some fields, and one of the fields is output directory. In front of output directory, you will write this. Also for the store GUI. The next step is that, so till here, we changed the output directory. Both the projects are have the same output directory now. And we know why. If you cannot remember, just go to the some minutes ago in the video file and you will find the answer. Now, we said that we have one include and one src file. In include, we are going to put the files that we are going to share with the user of our library. But since it's not, we said that our human.h, human.cpp would be in src, But we are going to also work with underline human.h. And as we saw, human.h should get inheritance from ihuman.h to implement its pure virtual function. But it should be able to see that if these files are in the src folder and the interface file is in the include folder, they cannot see each other. But how can we how can we solve this problem? Here, we will go to the project properties of the library, and in this path, VC++ directory, I will go to the include directory and write this one. I'm saying this path, project directory include. Project directory is where the project file is stored, and I'm saying that in that path we have one folder whose name is include. By doing that, the compiler knows that it should search in this folder as well to find those files, to find the file that it needs to include. For example, if in human.h we include i_human.h, which is stored in src folder, the compiler knows that it should search two different paths. One is src, where the human.h is stored, and the other one is this path that we are adding in the project properties, of the store. So this is the way that we can add and include directory to our project and ask and let the compiler be able to find the files that are stored in the include path. But this is not only for store. It should also be done for store GUI, because we are going to share these files stored in the include with store GUI as well. Include is for the store GUI, for a store library, but we are going to share it with store GUI as well. But how we can change it? Again, we will go to the project properties of store GUI by right-clicking on that and choosing properties from the menu that will be open. VC++ directory, include directory. If you click on this one, you will have this, and you will write this one here. What are we writing here? We are saying that the project directory, so this is the path. This is sorry. This is the path that the project directory, this is the path that is referring to the location that the store GUI project file is stored. And we know that it is stored in a store GUI, not in a store. For example, here we saw that this is the place that the project file for our library is stored. But for the other one, for the store GUI, the project file is stored in this path here. So to let the store GUI see the files stored in include, we go to the project properties of store GUI and we say that go to this address, ext, it is store and include. So search also in this path. If I include a file, you should search the file that is stored in the project directory, in the current path, and also in this path. So this is not the only thing that we need to do for a store GUI. So till now, we solved the problem for including the files from the libraries. But the library is not only the header files that we share. It also has some source codes. How those source codes are shared with the GUI? We said that we only have interfaces, and those interfaces has no code. How they are shared, I mean, how the human.cpp and human.age code will be shared with store GUI. Okay, the header file I_human.age, but the code will be shared with the store GUI in a DLL file and .lib file, which is generated by building store or the library file, the library project. So if you build the library project, it will lead to two files, .lib and .dll. And these two files are responsible for having those source code. But if we open them, we cannot read their code because they are some binary files and they are coded in a way that you cannot read the code. But to access those files, we in the first step, we change the output directory of both of them in the same location to be able to let the store GUI to see that .dll file generated by a store. But we also have a .lib file. To see that .lib file, we have to change the path here. We have a linker in the project properties of a store GUI. And here we have general, and we go to additional library directories. Again, we are telling to the linker, we had compiler, linkers, and runner of our program. We are saying to that search in this path if you need any library. So the path is that solution directory, build, platform, and configuration. This is the output directory that we define for our store, for our DLL. But we are saying now from solution directory where the file whose extension is .sln is stored, build, the platform, and configuration. So if when we are building store GUI, if it needs a .lib file, it will go to this path and search this path to find that .lib file. And if you open this one, probably by default you will see this, which is the path to the .lib file of your Qt directory. But if you do not have this one, add it yourself. It depends on the version of your Qt directory and Visual Studio, and in some versions you don't need to add that, but in some versions you need. But if it doesn't exist, you should add it, because again, you are going to work with Qt library, and to find those .lib files, you have to add it here, and the compiler knows that knows the location that should search, that should use to find that those lib files. So the next step is that you will go to this one, input. In additional dependency, you will write the name of the .lib files that you need. You should also do it for your Qt projects. If you use some abilities from your Qt library, and they are not header only, they are also have some codes, and if they have some coded, this means that there is a DLL file for them, there is a .lib file for them. You should write the name of those .lib files in this path. Here we are writing this one. So till here, those store.lib and store.dll is not generated yet because we haven't built the DLL project yet. So first we are going to define our classes in our library, and then we will build them. I'm not sure we will have enough time, but let's see. So in the store project, you will create a header file. You're familiar with that. You know how to create a header file. You will go just to this location, right click on header files, and you will add a new header file. It will be saved in src. You should choose this path for that because this is human.h, our source code that we are not going to share it directly with a store GUI. We write this piece of code there. It's as you can see, I'm using a namespace for my library. Why? Because I should know if I call human, it's coming from this library. This is helping me to know the location that where my classes is defined. When I'm calling human in a store GUI, I know that it's coming from a store. I know it's coming from this DLL, and that's why I put it in the namespace. This one is not implemented yet. Since it's not implemented, you can see the IntelliSense makes it like this. It has one data member. It has a constructor. I add one.cpp file to my store GUI. Again, to this, I will right click on source files here and add a new file. And when I add a new file, it will open this window, add a new item. I will write the name human.cpp in the same location. Again, this is not the file that you are going to directly share it with our store GUI. In the body of that, I will implement the constructor, and to implement that, I have to write store : human like this, because we define a namespace. You can add some members. This is the members that I'm adding to get ID, set height, another constructor, and some variables to my human.h, to my human class. Now I'm going to share this class with a store GUI. You don't have to write to share all of your classes that you have in your store library. You only write interfaces for the classes that you are going to share. You can have other classes that you won't share it with your I mean, you won't export it with your exported from your library. You can have. But now imagine we are going to share human with store GUI or any other projects. I will go to this address, create a file, I_human.h. I will go to here, a store. Here, I will right click on a source files, and then I will add a new item, which is I_human.cpp. Where do I put it? In src. The other one was in include. The header file is there, but the CPP file is in src. The name is I_human.cpp. So these are the files that you need to write for yourself. So human.h we just created. We just saw it in the previous examples. We also saw that human.cpp. These two were human.h, human.cpp, ihuman.cpp. All of them were in src folder. I_human was in include folder. What do we have in I_human.h? Here, similar to the previous one, pragma1 string memory, I will discuss about that later. We have again the namespace, a class whose name is ihuman. It has a pure virtual function getID, virtual pure. It has a virtual destructor, and I had to update this one like this. This class, this one, we said that this is an interface. So we have another class that is inherited from our interface, and it has to implement the pure virtual function of this interface class. Otherwise, this class will be an abstract class as well. As you can see, I only write a pure virtual function for getID. Even if we have setHeight, I didn't want to let the user access setHeight. Because of that, in the interface, even if it is public, I didn't write a pure virtual function for setHeight. So it's not really necessary to write a pure virtual function for all the members of this class. You only write the ones that you want to share with the other, outside of your library. But how can we export this object? We create a function in our library. It's not among this class. It's in our library. Okay. This function receives some arguments and returns an object, a shared pointer of ihuman. This one is implemented in I_human.cpp, again in our library, in our namespace. What does it do? It's creating an instance of human and convert it to a pointer of ihuman and return it back. In the store GUI, you have access to this one because we're going to export this. What does it do? It will says that if we are in first of all, this one is a macro that is defined by Visual Studio for your project. If you are in the in your library, this one is implemented. If you are in a store, this one is implemented. And if you are in store GUI, this one is not implemented. It's just a macro, is a variable that is defined automatically, but by your Visual Studio. So you are checking if this one is defined. It means that if you are in the store, if you are in the dynamic link library, use this one. Use this keyboard. What does it do? It's exporting the thing that you are writing here. So I write here store API, and since we are in the when we are using I_human.h in the library, in the store, it will export this. It will write here for you, export. But if we are using I_human.h in the store GUI, it will write here for you this one, import, because we are going to import it. because I underline human.h is something that is shared between the two projects. For one of the projects, it should be imported. For the other one, this function should be exported. So while you are in the library, this function should be exported. While you are in the store GUI, this function should be imported. So that's why we are writing this like that. We have just a couple of minutes. So the last step is include interface header files where you want to have access to the library. So you will add a push button and a label to your main window using Qt Designer. Okay, you can do it at home. You will see it's very easy. If you double click on the main underline window.ui, if you installed everything correctly, it should open your Qt Designer. Then in the left side, you have push button and a label. You will add a push button and a label to your project. You save it, and then you will build your solution. If you build your solution, your DLL and library will be created in this path. This is the path that you define because this is the output path of your library. This one will be generated in your generated file of your Qt project. This is the file that I said you should not change at all. If you do that, you will go to main window.h. You will see, you will have this structure. This is generated automatically, but you will add this thing as well. Here, this one is, this is the name of the push button. I changed the name to this. And then I'm saying that I will talk about the signals and styles later, but just to get the point about the interfaces, you will write this one. When you click on push button, this method, this slot will be called. Inside that, I'm now, since we exported getHuman, since we defined the project properties correctly, I have access to getHuman. I only include I_human.h. I can see human.h. I can only see ihuman.h, the interface. And I can only see ihuman. But in fact, we saw that in getHuman, we are sending an instance of the child, which is human. But the store GUI is not aware of that. It thinks that we are working with ihuman, but in fact, in the background, we are working with human. ihuman is just an interface, but it cannot see the code behind that. It can only see getID because ihuman only has one pure virtual function, which was getID, not the others. So what we are doing here, we are getting the ID of that, which is this one, and we are changing to a Qt string, and we are setting the text of the label that we define to this one. This is the name of that label that I changed myself. So this is the whole thing. Try to implement it by yourself. I know that it's getting complicated for you, but if you do it really at home by yourself, you will learn it easily. But if you postpone it and wait it just for the last lesson, it would be a big problem for you. So I really recommend you to do it in this week. If you have any question, you can ask. Otherwise, we only have 2 minutes. No question?
And for the project, what files should we set?
Oh, I forgot. Oof. Thank you for saying that. As you can see here, this is, you just saw that we have a store GUI, we have exts, a store. But for your first project, you don't have this folder, okay? You only have this store GUI and one build probably, and also this one. If you have this, delete this one, delete this one, just show the hidden files as well. Delete these 2 folders, and also this one. For you, it might be x32. Delete these files and then only send the source codes, not the because these are the generated file, your exe files, your build files. I don't need them, and they are usually take much memory, these things.
If I just send you only the header and source files, is that okay as well?
No, because I cannot open it in Visual Studio then. Make it as a zip file, all of them, but just delete the file, the folders that I just mentioned.
I don't see the folders.
I
you're
can.
talking about.
Probably you have this one. I think you, for sure you have this. You can share it with me if I don't know. You can share.
Yes, wait.
Can you share?
I can. No, I saved my solution over here, and then just have the solution file, and then member directory subfile with all the
So
source.
delete the debug folder here and also the folder above.
Okay. So I just delete those two, but I
No,
don't
no, no,
have.
not this one. I mean, just this debug folder and not the main member directly. I cannot read it. It's very. So just this debug folder
and
and
then
go up, go to the previous path.
Okay, and then that one is
And also this debug folder, yes. And if you then, I mean, you only need to zip the member directory. I mean, the one above this. Go to the member directory, the one above.
Yes, I need to just zip this one and then.
Just zip this one in and send it to me. And I think it would be even now. It's not really hard.
Okay. Super. Okay. Thank you.
You're welcome.